Howdy, I'm Denise from MathforAll, where everyone can learn more about math. You have learned how to solve systems of equations using graphing, substitution, and elimination. Today, we'll see that sometimes these work out, well, in a strange sort of way. I'll show you the 3 things that can happen when we solve these. First, the type that we're used to so far and the most common, 2 lines that intersect at one point like this. As we solve these, our variables equal numbers and we give the answer as a point. No problem there. These next 2 get strange. The second thing that can happen is that we could have 2 lines that are parallel. You can see that they will never have the same x and y values, so the answer is no solutions. When we solve these, all of our variables go away, and as we keep going, we'll get 0 equals some number, but not 0, and that is never true. Since it's never true, that's when you think there are no solutions. The third thing that can happen is the system may be the same lines, but they move numbers around so that it's not super obvious. When we go along our merry way and solve these, the variable will also go away. But this time the numbers will too, and you'll wind up with 0 equals 0, which is always true. The answer then is all real numbers. Let's try a few strange ones so you can see what I mean. Solve 3x minus 4y equals 7 and y equals 3/4 x minus 7/4. We get to choose how we want to solve this guy. I think we should choose substitution. Do you see why? That y that equals stuff makes it nice to plop into the other equation. We'll go for it. 3x minus 4 times parentheses 3/4 x minus 7/4 equals 7. These fractions look scary, but it's going to work out for us because we're multiplying by the denominator. 3x, then distribute the -4 for negative 3x plus 7 equals 7. Simplifying, 3x minus 3x equals 0, then 7 equals 7. We could subtract 7 from both sides to get 0 equals 0, but that's not necessary. Since 7 always equals 7 and 0 always equals 0, these 2 are the same lines. All real numbers will work. That's pretty cool. We have one more example of strange equations. Solve 4/5 x minus 3/5 y equals 3.6 and 8x equals 6y plus 72. Honestly, this one looks a little difficult. We'll have to use some algebra skills before we can even start. None of the variables will be nice to solve for, so I think I will get these set up to solve by elimination. First, I have to stack them nicely. I'll just bring over the 6y in the second equation for 8x minus 6y equals 72. Okay, now the top equation with those fractions, bleh, we can clear them by multiplying all terms by 5. 4x minus 3y equals 3.6 times 5, which equals 18. Ah, that looks so much better. I'll choose to eliminate these x's by multiplying this one by -2 for negative 8x plus 6y equals negative 36. Now add them up and you'll see what happens. X's and y's are gone for 0 on this side. On the other side, I have 72 minus 36, which equals 36. But 0 can't ever equal 36. So these lines are parallel and there is no solution of where they meet. Congratulations on sticking with the lesson titled Strange Solutions. If weird things happen as you're solving systems of equations, now you know how to handle them. We have more strange math and some not so strange math to learn, so keep watching videos to learn more about math.